Modern large language model agents accumulate experience in two distinct ways. They gather textual knowledge, in-context learning, retrieved memories, and system prompts, and they acquire parametric skills by updating their weights, typically through parameter-efficient fine-tuning or cache saving. Suppose an agent has a tuned module for translating English to Twi, and a separate module for analyzing complex legal documents. If the agent needs a legal documents in Twi skill, it must compose those two experiences. The textual route allows you to paste the instructions for both skills into a single prompt. This is flexible, but computationally expensive, and bounded by the context window limit of the model. This diagram illustrates the two unimodal extremes. If we look at the parametric side on the right, you can mathematically average the weight matrices of both skills to save compute. But arithmetic merging is completely blind to the actual functional relationships detailed in the text. It cannot follow a logical instruction. There is no existing mechanism to simultaneously compute over textual instructions and raw parametric weights. True instruction-steerable skill composition remains impossible. A 2026 paper from DeepMind, called SkillSmith, proposes a distinct solution. Model weights do not have to be treated as opaque mathematical artifacts. An LLM can treat weights as a first-class, readable, and synthesizable modality. To build a bridge between text and weights, the engineering question is, which parameter-efficient fine-tuning method should serve as the carrier? Standard LoRa weight deltas exist in an alien representational space compared to text tokens. Forcing an architecture to ingest raw matrix updates alongside text requires mapping across entirely separate spaces. This flow diagram shows why prefix-tuning KV caches are the mathematically sound alternative. Text tokens naturally convert into a key value cache during a standard forward pass. Both the text and the prefix-tuning weights ultimately manifest as attention-readable KV blocks. By utilizing prefix KV as the carrier, the architecture only needs to map between two regions of the exact same representational space. To process these inputs, SkillSmith packages each source skill into a task bundle. A bundle pairs a prefix KV cache with its textual metadata, which might include in-context learning exemplars or past reflections. The augmented Gemma coprocessor needs a specific entry mechanism to ingest that raw weight KV data. This transformation relies on an input KV adapter. It is a multi-layer perceptron designed to project the raw weight space KV into the LLM's latency. Once projected into the latent space, the LLM's attention layers can attend to these adapted weights precisely as if they were standard text tokens. The input adapter converts an executable parameter file into a readable token equivalent. Reasoning over multiple text and weight bundles simultaneously can rapidly devolve into an unbounded graph problem without strict structural constraints. SkillSmith solves this with a control token grammar, opening the sequence with a preamble that states the compositional objective in plain text. This sequence layout demonstrates the strict per-bundle formatting. The sequence uses specific control tokens, source start, KV start, and KV end, to explicitly delimit the text metadata and the adapted KV weights. The attention mechanism knows exactly where each modality begins and ends. After all source bundles are appended, combination text is inserted. This provides the textual instruction detailing exactly how the preceding sources must compose. This strict grammar collapses a bimodal composition problem into one sequence. At the end sits a generation block, a fixed-length run of placeholder tokens, bracketed by generation tags. The coprocessor runs a single forward pass over this interleaved sequence. SkillSmith does not auto-regressively decode new weights as tokens. There is no token-by-token loop. Synthesis is achieved by directly reading the KV cache generated at the specific positions of those placeholder tokens. Because there are a fixed number of placeholders, the output length is strictly fixed. However, the forward pass injects rotary position embeddings. The extracted KV cache is artificially tied to its placeholder position at the end of the sequence, making it useless as a general prefix. To solve this, an inverse rope transformation is applied to strip away the positional data. The derotated cache then passes through an out KV adapter, mapping it back to a deployable weight space. Extracting placeholder KV and derotating it yields a portable, position-agnostic weight matrix in a fraction of the compute time required for autoregressive decoding. The input and out adapters must be trained. If they are trained on a simple reconstruction proxy, like mimicking a merged average, they fail to capture complex task behaviors. Instead, the adapters are meta-trained end-to-end by minimizing the downstream task cross-entropy of a completely frozen base model. This visual maps the differentiable stack. The SkillSmith coprocessor outputs a prefix. That prefix snaps onto the frozen base model, which makes a prediction. Gradients backpropagate directly through the frozen base to explicitly update the parameters of the SkillSmith adapters. To supply enough meta-training signal, researchers utilized composite SNI, generating 17,000 synthetic compositional tasks to provide ground truth source-to-target mappings. Because the gradients flow backwards strictly based on task success, the synthesized prefixes are optimized for task performance. This makes them highly effective initializations for downstream fine-tuning. The primary critique of any bimodal system is whether the model is genuinely reasoning over the weights or just achieving higher performance due to the rich text metadata included in the prompt. This chart tracks global ELO scores across different input conditions. Performance degrades in strict monotonic order when inputs are removed. Adding prefix weights on top of text delivers a 92-point increase in global ELO. Text contributes the heaviest baseline performance, but the system relies on both modalities to hit its peak output. As an additional control, researchers fed a direct training baseline the entirety of SkillSmiths. It still underperformed the bimodal approach. The measurable gains stem directly from synergistic text and weight synthesis. SkillSmith dominates specifically in regimes of extreme data scarcity, such as the MMLU-ProX dataset, and it provides an exceptional baseline initialization for fine-tuning. The architecture does have boundaries. The evaluations rely on judge-fragile ELO rather than raw accuracy. All tests were constrained to a single 4 billion parameter Gemma backbone, and carrier independence for methods outside of prefix tuning, like LoRa, remains untested. Neural weights no longer need to be treated strictly as opaque mathematical matrices destined for blunt arithmetic averaging. They are a native, readable modality that large language models can reason over and synthesize directly.